Institute of Engineering and Technology. Now today we are going to study a new topic of Laplace transform. So let's begin with the first topic, that is first shifting theorem. Now if Laplace transform of ft is equal to f of s, we know this Laplace transform of ft is fs, and Laplace transform of e raised to at ft is what? F of s minus a. Okay, so if firstly what we have to do, we have to find the Laplace transform of ft and we will get some function in terms of s. Okay, and if we will apply e raised to at to this function, what we have to do, in place of s we have to just write s minus a. Okay, now let's say its proof. So Laplace transform of ft is integration 0 to infinite e raised to minus st ft dt. Okay, this is the main formula. Now we have to find the Laplace transform of e raised to at ft. So we will write Laplace transform of e raised to at ft is equal to integration 0 to infinite this e raised to minus st as it is. In place of ft we will write e raised to at ft dt. Okay, now integration 0 to infinite e raised to, take minus common, so here we have s minus a t ft dt. Okay, next so this is what it is, f of s minus a. Okay, now we know that this answer is fs, right? So here we have s, so we have fs, and here we have s minus a, so we'll write f of s minus a. So this is the proof of first shifting theorem. Okay, now we'll solve the example. Find the Laplace transform of e raised to 2t sine square t. Okay, so we have to find this e raised to 2t sine square 3t. Okay, so for that what we will do, firstly we will find Laplace transform of sine square 3t. Now we cannot find directly Laplace transform of sine square 3t. Okay, so we have to convert it using a formula. So this is 1 minus cos 60 upon 2. Okay, we know this formula. Now apply the linearity property, so 1 by 2 we will take outside. Here we have Laplace transform of 1 minus Laplace transform of cos 60. Okay, now we know Laplace transform of 1. Okay, this is 1 upon s, this we have proved. So just use this. So it is 1 upon s minus, now Laplace transform of cos 80. This is the formula, that is s upon s square plus a square, right? So here a is 6. So we have s upon s square plus 36. Correct? So this is the Laplace transform of sine square 3t. Now in this, if we are applying e raised to 2t sine square 3t. Okay, so what we have to do in this answer, in place of s we will write s minus 2. Here we have plus 2, so we will write s minus 2. If we have minus 2, then we will write s plus 2. Okay, so here plus 2, so just write down s minus 2. This 1 by 2, 1 upon, in place of s minus 2. Make sure to write s minus 2 in every s. Okay, so here we have s, so s minus 2. Here s minus 2 whole square plus 36. Okay, so this is the final answer of Laplace transform of e raised to 2t sine square 3t. Correct? Now let's solve one more example. So here we have to find Laplace transform of e raised to t plus 1 whole square. Right? So for that what we'll do, firstly we will find Laplace transform of t plus 1 whole square. Right? So just expand this, so we will get t square plus 2t plus 1. Apply the linearity property, so Laplace transform of t square plus 2 times Laplace transform of t plus Laplace transform of 1. Okay, now we know this formula, Laplace transform of t raised to n is what? N factorial upon s raised to n plus 1. Okay, here n is 2, so we will get 2 factorial upon s raised to n plus 1, so we will get 3 plus 2 as it is. Now here n is what? 1, so we will get 1 factorial upon s square. Okay, and Laplace transform of 1 is 1 upon s, simplify, so this is 2 upon s cube plus 2 upon s square plus 1 upon s. Okay, so this is the Laplace transform of t plus 1 whole square. Now just apply e raised to t. Okay, so t plus 1 whole square. Here we have 2. Now here we have coefficient as a 1. Okay, so in place of s we have to write just s minus 1. So s minus 1 whole cube plus 2 upon s minus 1 whole square plus 1 upon s minus 1. Okay, so this is the final answer of this. Clear? Now let's solve one more example. Laplace transform of e raised to minus 3t 2 cos 5t minus 3 sin 5t. Okay, so what we will do, firstly we will find Laplace transform of this term. Okay, so apply the linearity property. So 2 times Laplace transform of cos 5t minus 3 times Laplace transform of sin 5t. Correct? Now we know Laplace transform of cos 8t is what? S upon s square plus a square, and Laplace transform of sin 8t is what? A upon s square plus a square. Correct? Now here 2 as it is. Now here a is 5. So what you will get? S upon s square plus 25 minus 3 times, again here a is 5. So 5 upon s square plus 25. Okay, just simplify. So this is 2s upon s square plus 25 minus 15 upon s square plus 25. Okay. Now in this we have to apply e raised to minus 3t. Okay, and this 2 cos 5t minus 3 sin 5t. So what we have to do? Now here we have minus 3. So in place of s we have to write s plus 3. Okay, so in everywhere here in place of s just write down s plus 3. So 2 times s plus 3 upon s plus 3 whole square plus 25 minus 50 upon s plus 3 whole square plus 25. Okay, so this is your final answer. Okay, now we'll begin with a new topic, that is differentiation of Laplace transform. If Laplace transform of ft is equal to fs, then Laplace transform of t raised to n ft is what? Minus 1 raised to n d raised to n upon ds raised to n fs. Okay, so whenever we are applying t raised to n to this ft, what we have to do? We have to apply this formula, that is minus 1 raised to n d raised to n upon ds raised to n fs. Now firstly we will prove this. So Laplace transform of ft, this we know, we can denote it as f of s, right? This is integration 0 to infinite e raised to minus st ft dt, main formula. Okay, now what we will do, we will just differentiate both the side with respect to s. Okay, so what we will get? D by ds of fs is equal to d by ds integration 0 to infinite e raised to minus st ft dt. Okay, now we'll take this differentiation inside the integration. Okay, and here we have two variables, so it will become del by del s of e raised to minus st ft dt, left side as it is. Okay, now what we have to do, we have to find the derivative of this term with respect to s, and we will keep t as a constant. Okay, so derivative of e raised to minus st will be e raised to minus st into minus t. Why? Because t is constant and we are differentiating with respect to s, and this ft dt as it is. Okay, now just simplify this. Take minus outside, integration 0 to infinite e raised to minus st. Bring this t and ft together, so here we have t and t. Okay, now this we can write as Laplace transform of t and t. Okay, this integration we can write as Laplace transform of t and t. Okay, and just bring minus side over here. So this is minus d by ds of fs. Okay, so for n is equal to 1, we have this formula, that is minus d by ds of fs. Okay, now for n is equal to 2, what we will get? Laplace transform of t square ft is what? Minus 1 square, that is plus 1 d square by ds square of fs. Okay, so in general we can write Laplace transform of t raised to n f of t is minus 1 raised to n d raised to n upon ds raised to n fs. So mainly if we are multiplying only t, okay, so we will directly use this formula, that is minus d by ds of fs. If we have t square, then it is here it will become plus, so plus d square by ds square of fs. And suppose if we want to find Laplace transform of t cube ft, okay, so it will become minus d cube by ds cube of fs. Okay, so now let's solve the examples. So here we have to find Laplace transform of t sin h in t. Okay, so we know this formula, Laplace transform of TF. T is what? Minus d by ds of Fs. Okay, so firstly we need to find Fs, and Fs is what? It is Laplace transform of Ft. So first we will find Laplace transform of sin hat. Now we know the formula. It is a upon s square minus a square. Make sure whenever we have a hyperbolic function, we have negative sign over here. Okay, so a upon s square minus a square. Now just apply t. So this is t sin at a t. It is what? Minus d by ds of, this is our fs. Okay, so minus d by ds of a upon s square minus a square. So we have to differentiate this. So apply the division rule formula. Okay, so this denominator, as it is derivative of numerator, here we have to differentiate with respect to s, so its derivative is 0 minus numerator, as it is derivative of denominator is 2s upon denominator square, so s square minus a square whole square. Okay, now this term is 0. Here what you will get, this minus and minus will become plus, so we have 2as upon s square minus a square whole square. Okay, so this is the answer of Laplace transform of t sin hat. Now next one, find Laplace transform of t sin square 3t. Okay, so what we will do, first we will find Laplace transform of sin square 3t. Okay, this is easy. This we can write as 1 minus cos 60 upon 2. Okay, take 1 by 2 outside. Laplace transform of 1 is 1 upon s minus. Laplace transform of cos 60 is s upon s square plus 36. Okay, now just apply t to this. So t sin square 3t. Okay, now we know this formula, Laplace transform of tft is minus d by ds of fs. Okay, so this is minus d by ds of fs is this term, so this is 1 by 2, 1 upon s minus s upon s square plus 36. Okay, this minus 1 by 2 outside, derivative of 1 upon s is what? Minus 1 upon s square. Okay, minus. Now again here we have to apply the division rule. So s square plus 36, as it is derivative of s is 1 minus numerator as it is, means s as it is, derivative of denominator is 2s upon s square plus 36 whole square, right? Just simplify, minus 1 upon 2 minus 1 upon s square, here minus as it is. Now here s square plus 36 minus 2s square upon s square plus 36 whole square. Okay, just simplify this term. So what you will get? Minus 1 upon 2, here minus 1 upon s square minus. Now s square minus 2s square. Okay, so it will give you, so 36 minus s square upon s square plus 36 whole square. You can take this negative common from both the term. Okay, so this will become plus, so 1 by 2, 1 upon s square plus 36 minus s square upon s square plus 36 whole square. Okay, so this is your final answer of Laplace transform of t sin square 3t. Now next example, find Laplace transform of t e raised to 4t cos 2t. Okay, now here we have to apply both the formula, that is the first shifting theorem and this differentiation formula. Okay, so firstly we will find Laplace transform of cos 2t, that is s upon s square plus 4. Now first we will apply t. So t cos 2t. Okay, so if we are applying t, so what is the formula? Minus d by ds of fs, and fs is s upon s square plus 4. Okay, apply the division formula. Okay, so denominator as it is, derivative of numerator is 1 minus numerator as it is, derivative of denominator upon denominator square, right? So on simplification we will get s square plus 4 minus 2s square upon s square plus 4 whole square. Simplify this. Okay, apply minus sign inside. So what you will get here? S square minus 2s square, that is minus s square. Apply, so negative sign, so here we have s square minus 4 upon s square plus 4 whole square. Okay, now in this answer we have to apply e raised to 4t. Okay, so e raised to 4t into t cos 2t. So if we are applying e raised to 40 means what? In place of s we have to write s minus 4, right? So in this answer, in place of s, just write down s minus 4. So this is s minus 4 whole square minus 4 upon s minus 4 whole square plus 4 whole square. Okay, this is your final answer of t e raised to 40 cos 2t. Okay, so I hope you have understood both the topic. Thank you for watching.